Okay, let's get started. So it's worth knowing that right now Synergy is being really funny. Yesterday there was a big syncing issue between Google Classroom and Synergy. So go off what is in Google Classroom for your marking period 1 grade. Worst case, I will, if it doesn't match, I'll give you the Google Classroom grade. That should be more accurate. So there was one request on a problem to review. I will do that after today's short lecture. So on for us, I think that was Monday, we talked about nested loops. We ended with a problem that looked like this. 8 rows, 6 columns, and getting that pattern. And it uses this idea of a nested loop, a loop inside a loop. One thing that I kind of skipped over, and I was meeting with Mr. Simon on Monday, is that, we kind of jumped straight into for loops. And that might be a big jump for some of you. So I wanted to take the time to review the difference and translating between for loops and while loops. They do the same thing, right? They repeat things, they have a start, they have a stopping condition, a continuing condition, and they have an increment. So why would you use one over the other? So you have these reasons. In Java, for loops, you would want to use a for loop because you know exactly how many repetitions you want. So let's say you wanted to make like 8 rows, you only repeat the lines of code or that ellipse code 8 times. Sure, done. But for while loops, you may be unsure about when you stop. A really good example of this is with the lightning assignment. It suits itself to a while loop because you don't know how many kinks and points and whatever they are, bends there are in your lightning bolt. Could be 100, could be 50, could be 77, so on and so forth. But you know that your program needs to stop when it gets to the end of the page, or the right-hand side of your screen, right? You know, that start X is like greater or less than whatever your canvas size was. So that's a great example of when to use a while loop. The variable that mattered was start X. It was initialized in front and the top part of your program. The increment was a little different. It wasn't like start X equals start X plus 1, right? Start X plus plus to march itself forward. You added a bit of randomness there. So there's like skips and jumps. On the top here, you have a while loop. If you had me previously for a programming class, I very intentionally kept any loop that I used a while loop because it separated clearly those 3 parts, right? The initialization and declaration of your variable, the condition, and then the increment. And I think I'm still going to be using while loops instead of for loops for a little bit more time. I'm still going to stick here, even though we could jump to using for loops. I want you to develop that level of fluency and where these lines of code occur before I jump here. So with a little bit of color coding, you see where these things are. These two, I think, make sense. It's this line of code I wanted to point out. You increment at the very end of whatever you're repeating, right? X equals X plus 2. I believe that some of that meaning is lost when you squish it all into a for loop over here. Another thing that's different is that with for loops, just syntactically, we notice that the semicolons have to be here, right, in between, versus for while loops, it's here, and then there's no semicolon here, right? Subtle differences that may trip you up. Right? And then there's no semicolon at the end of this one. Strange, isn't it? So take a moment, look at this line of code. Can you find the mistake? For those that just joined, we are looking at this for loop. There is a particularly nasty mistake. Can you find it? It doesn't work as intended. You're talking about right over here, right? Kind of flashed it for a second. Right there? Nope. Space there won't matter as much. Yep, right here. That's particularly nasty. So there is a semicolon at the end that will prevent this for loop from executing. And a follow-up question is, how many X's will you see to the screen? Can you think through that in your brains? Very good. Some of you have private messaged me, that is correct. How many X's will you see to the screen? How are they oriented? Is it a row or a column? Think about that for a couple seconds. And at this point, I'll talk through it. So you should see, let's see, 5, 6, 7, 8, actually no, we're incrementing by 2, oops, 5, 7, 9. And then when you get to 11, that's too much, so then I should expect to see 3 X's. Notice that it says print line here, so there are 3 X's in a column, right, on top of one another. Gotta be careful. So first I was looking here, then I was looking here, and then I kind of ignored the increment. It's +2 at first, but I was thinking +1. So I went back and said 5, okay, that's where I start, add 2, 7, 9. Each time I'm checking, is it less than 10? Great. Then I print an X. I highly recommend you play the role of computer. You predict what the output is, and then you like copy and paste this code or press the play button with processing to confirm like whatever you're thinking. Yeah. So there's the mistake fixed, right? Semicolon disappears. A little bit more about grades. The last thing to be graded in marking period 3 is the nested loop worksheet and the functions 3. So that got kind of cut off here, but functions 3. There is a request for one problem to review, so I will talk about the first problem in functions 3. Take the time to also sign up for my AP Classroom. My Google or AP Classroom code for this particular block is posted in our Block 6 Google Classroom, so use that. So take the time, if you haven't done that, to do that now. You can continue working on the nested loop worksheet or functions 3. I will be reviewing the first problem for functions 3, and if there are more requests, then do ask them now so I know to get to them. Here's the problem that was requested. The first one from functions 3, APCSA primitives check and. So this one, return true if both inputs are true, otherwise return false. So pretty much what we're doing is recreating this symbol, right, the ampersands, the and logical operator. Why is it logical? Because it deals with booleans. It's not relational because that implies like superiority or something's bigger than the other. That's less than, equal to, or greater than, equal to. So you notice, right, the things you're familiar with is true and true yields true, right? The overall statement is true. That's the example presented here. But now you have a function, APCS check and. Oops. Oh gosh, come on. True and false gives you false, right? So that's how this input is, that's what it's pretty much saying to us. We're familiar with these ideas, but we're writing it a different way. False and true gives you false, so on and so forth. So a couple ways you can go about it, right? You could check with if statements each thing and think about the combination of each one. For example, if we want to identify this case right here, if first is in fact, lowercase, right, true, and then if second equals true, then what do we do? What do we return? We return true. As of right now, it's going to complain. We're going to see this error where it says missing return statement. That means we have to have a return here. It expects a boolean, so that's true or false. Pick one, doesn't really matter. We can say, if you ever get to the end, because we're not done with the problem just yet, return true. Look at that. Oh darn. You could cheat and do like something like this, right? And then I'd be done. But there's more going on, right? Like I wouldn't give, well, I guess I could give you full credit for this. But it's a little weird. This is like routine, right? There is a more efficient way to go about this. Shoot, I didn't intend on showing you the entire thing, but this problem's simple enough. There is a way to do it in just one line, and I encourage you all to think about and try that out, okay? Hope that's helpful. Triangular numbers and products of sevens. Yes, let's go over those problems. Oh, sum of sevens, not products of sevens, because the two are like, I think sum is easier, and then the product, yeah, good job. Yeah, sum of sevens, okay. So let me close this one. Very good. Some students are messaging me about the one-line answer. Good job. That is in fact how you do it. Triangular numbers. So it looks like a pyramid, right? There's 1, there's 2 and 2, there's 3, 3 and 3, and then if you space it out, you see your triangle. This line gives us 1, this line gives us 3, this line gives us 6, right? Yeah. So with triangular numbers, first understand the relationship between your input and your output. Read through this paragraph and try to translate into code. Topmost row has 1 block, yeah. The next row has 2 blocks, so I use the number 2 to stand in for 2 blocks, also being the second row. This one is the third row, so it has 3 blocks, and I'm denoting it's a third row with the letter or number 3. And now we got to return the total number of blocks in the triangle. So right off the bat, maybe I just want to return 0. I just see a bunch of red. Hey, look, I got the first test case. When I am at no rows, then of course I have no blocks in my triangle. Cool. It's off to a good start. This is also a good habit I want you all to develop. Return the correct data type at the very end, or somewhere in your program. Look at the return type of the function. See that it's an int, so give it an int. That's a guaranteed point on your FRQs in the APCSA test. So build the habit now. Alright, now things get more complicated. N here represents the number of rows. Maybe we can think, okay, there should be some kind of mathematical formula for this. Maybe I can just return the number of rows. And it works for the first one. But then the rest of it, it doesn't, yeah? It cuts out. So we got to do something a little bit more complicated. When I look at this and I see rows, notice how it's moving down. I'm seeing some repetition. So I'm getting hints that I should probably use a loop in here. I like I. So my counter is going to begin at 0, while I is less than something, probably n, because that's the number of rows. I'm going to be repeating something. I'm going to be growing by 1 each time. The shorthand for this being I++. Then our question is, what the heck goes here? I hope you're seeing in coding bat, there's often this pattern where you declare some kind of number, either an int or a double, and that's going to contain your answer. Call it what you will. Call it your sum. Call it your triangle, right? Triangular number or tri-number. Started at 0. Why do we start at 0? Well, it's a nice number to start with, right? If you have nothing, then return nothing. As we think, okay, n represents the number of rows. Really, this thing is a summation, right? It's a running summation. So whatever goes into the question marks here should read something like whatever your sum is, update it with your current row number. So in this example, you would do, like, how did we get 3? We got that from 1 plus 2. How did we get 6? We got that from 1 plus 2 plus 3. Right? If I'm using sigma notation, for those that are in Algebra 2, right? Sigma n, that's what's happening here. That's the formula you're translating into code. And that concludes my hints for triangular numbers. Hope that's useful. Moving on to sum of sevens next, unless there are more questions. All right, sum of sevens. So with this problem, it's still a summation, right? It's related to the previous one in that we're using a loop, we're adding things, but now there's this divided by 7 idea. So if I see that kind of pattern, since I have this code conveniently here, I'm just going to go ahead and borrow it, post it into here, and let's see what happens. Okay, that's nice. It's completely off, but hey, I got the first one. Input of 0, return 0. Now, let's try to tackle this first case, right? The first case, when at the beginning, when you start, you should return 1/7. So maybe, yeah, follow through with order of operations. Whatever I'm repeating, maybe answer equals 1/7. And then instead of returning n, I return answer. Semicolon. Darn it. I return nothing. Why is that? So I expected this one to turn red, and I expected this one to turn green, because I was trying to return 1/7, but it seemed to not like what's happening here. If you look at my code right now, can you think about what the error is? Why did I get 0 for this output right here? I thought it would return 1/7. Very good. One student's got it. You can private message me or post it in the chat. It's kind of subtle, the error that is present. Good. 2 students have gotten it. It's been a while since we talked about this type of error. All right, 3 students. It's not so much parentheses being here. I think, since there's only 2 operations, right, it's still division. Yeah. It's the part that I'm returning an integer right here, answer. And so one student said integer division. Yeah, that's what's happening here. When you do 1 divided by 7, that gives you 0.142, right? But only if it's a double. If it's integers, it chops off the decimal places, and now it makes sense why you're seeing 0 for like everything, or like at this point. It also makes sense for everything else because the answer is always 1/7. So one way to make that change is to change the data type of your answer variable. It should be a double. What did I do now? I made it 0. My increment is always growing by 1, and then I return answer. Okay, I'm still not seeing it here. So what's going on? Any other ideas on how to get like 1/7 to appear in the run column? I changed double, or maybe I should do something like this. Nah. That's fine. So any more guesses? That's definitely related to the issue, but something odd is happening. Right? Even then, right? It happens. Very good. Jack says use a cast. There's our 1/7. So if you remember, right now I typed it out as integer divided by integer, right? Another way to fix that, besides using a cast like this, is adding in the decimal place, I believe, right? Because then it sees double. It says the computer sees that, oh, this guy wants a decimal in there, so I probably should return a decimal. See that? So our mistake lies in this formatting. Cool, so we got 2 test cases. So check your data types is the main lesson highlighted for my mistakes in sum of sevenths. Are there other coding bat problems you want me to review? Double check the time. Questions about what I just talked about? All right. So the rest of the time, you can go. You can also stay and work on things. I'll be here until the end of class. For the video, I'm going to